All right, so today we're going to finish our review of logs and exponents. We're just going to be going over solving basic logarithmic equations. So we'll remember from our previous videos that logs and exponents are inverses of each other. So we saw that if we have e to the x and we take the natural log, we'll get back x. And that's because if we take the log of any number where the base and the argument are the same number, we're just going to get back 1. So log base 10 of 10 is 1, ln of e is 1. So any log where you have these two numbers are the same is going to be equal to 1. And that's because anything raised to the power of 1 is itself again. And now the same goes for if we did 10 and then raised it to some log, let's say log x, this would also be equal to just x. And this is because, let's look at if we do 10 to the log of 100, and this is base 10, this log. So we know that log of 100 is asking us, okay, what power do I have to raise 10 to in order to get 100, right? That's what log of 100 is telling us. Well, we know that log of 100 is equal to 2, right? Because I have to raise 10 to the power of 2 to get 100. So this is equal to 2. So now obviously, if I then raise 10 to the power of 2, I'm going to get 100. And that will be true for any x that you put here. So this is what we're going to be using to solve all of our logarithmic equations. So in our previous example, when we had exponential equations, we would take the log of both sides. Now we're going to be exponentiating both sides. So let's just do a very easy example in base 10. So let's say I have log base 10 of x is equal to 3. Now we can figure out, again, by eyeballing what x is equal to, but let's do it the long way. So what I want to do is basically raise or make both sides of this equation the exponent in my new equation. So I'm going to have 10 raised to the power of log base 10 of x equals 10 to the 3. So now I know that 10 log 10, that will basically cancel out. So I'm left with x is equal to 10 to the 3, which we know is 1,000. So we get x is equal to 1,000. Okay, now let's do a slightly more challenging example in a different base. So now we have log base 2 of 25 minus x is equal to 3. We obviously want to find x. So what we're going to do now is raise both sides of the equation, make it the exponent with a base of 2. So it's very important in these problems that we use the same base. So we had base 2 there, so we have to use our base for our new exponential equation. We have to use base 2 again. Otherwise, our simplifying, canceling out doesn't work. If you were to do like 2 log base 10 of x, that is not equal to x. So you have to use the same bases in this case, which is different than in our previous video. We didn't necessarily need to use the same base for it to work out because we could use a change of base formula. But in these equations, you absolutely do need to use the same base. So we need to use 2 here because we have base 2 in our log. So now on our left-hand side, the 2 and the log basically cancel each other out. So we're left with 25 minus x is equal to 2 to the 3. And 2 to the 3 is equal to 8. So we have 25 minus x is equal to 8. We solve for x, and we get x is equal to 17. All right, now let's do another example. So this one, since we don't have a base listed, we're going to assume base 10. So I can't just dive right in here and do like 10 and 10 and, raise everything here. Because 10 to the 4 plus 3 log 2x, that doesn't really help us right away. So what we want to do is simplify our equation so that we have like just log equals some number. So I'm going to simplify this a little bit so that we have 3 log of 2x is equal to 12. And then I'm going to divide both sides by 3 so that I get log of 2x is equal to 4. And now I'm going to take my 10 and exponentiate my equation. So I have 10 to the log 2x equals 10 to the 4. So now I just have 2x is equal to 10 to the 4 because those went away. And now I can divide both sides by 2. So 10 to the 4 is equal to 10,000. So I'm going to divide both sides by 2, and I get x is equal to 5,000. Now for this one, if you wanted to, like in the beginning, if you wanted to say, okay, we're going to just go ahead and raise it, exponentiate it right here, and then break this up into 10 to the 4 and 10 to the 3 log 2x and solve your equation that way. You could do that, but to me that's a lot more complicated. You've got a lot of exponents floating around. So I would always recommend condensing your equation first down into just a log of something with x equals and just some number on the other side first. A lot less room for mistakes that way. All right, now let's look at an example that has 2 logs. So again, we can assume base 10 here. So what I want to do is let's use our log rule and combine these 2 logs. Now, just like in our previous example, there's a couple different ways you could approach this with the algebra. I'm doing it the way that I personally find easiest. So what I would do first is use my log rules to combine these 2. So I would have log x plus 2 and x minus 1 equals 1. And now I would exponentiate, so I have 10 and 10 here. So then I have x plus 2, x minus 1 is equal to just 10 to the 1, which is 10. And now this is sort of like a quadratic, so I can just factor this and solve it like a quadratic. So here I'm going to have x squared minus 1x plus 2x, which will give me plus x minus 2 is equal to 10. So then I'll have x squared plus x minus 12 is equal to 0. And now this I can just factor into x plus 4 and x minus 3. And now this gives me solutions of x is equal to -4 and +3. So now here, we have to take a second and think about our answers. So I have x is equal to -4 and +3. Now, normally you always want to check your solutions whenever you get x. You always want to plug it back into your equation and make sure that it actually works. And in this one, it's extra important to do that because here, if I plug in -4, so if I have -4 plus 2, that's obviously going to give me a -2 here. And then I have a -4 minus 1. Well, now I'm trying to take a log of a negative number, and we know that that doesn't make any sense. So my x is equal to -4 is not actually a solution. So I'm rejecting that solution. And now I'm going to just look at my remaining solution, which is +3. So my x is equal to +3. Now that does work. If I plug in +3 here, I have 3 plus 2, which is 5, so I can take the log of 5. And then I have 3 minus 1, which is 2. I can take the log of 2. And everything works out. And when you plug that into your calculator, you end up with 1. So this is my only solution, even though it initially seemed like I actually had 2 solutions. Only one works. So whenever you're doing equations where you have something like a log where if you take a log of a negative number, it's going to be undefined. Anytime you have something where your equation can be undefined, you always want to check your answers and make sure that they don't give you something that's undefined. Okay, so now let's look at another problem. So here we have a bunch of logs. So I'm going to condense these 2 sides into a log and a log on each side. So I'm going to use my log rules and write it as log of 3x base 2. So I have base 2 here is equal to log of 5x minus 2 on the other side, base 2. Okay, and now I can just exponentiate everything. So I have 2. Remember, you always want to use the same base. So I have 2 and 2 here. So I have 2 to the log 3x and 2 to the log base 2 of 5x minus 2. So now I have 3x is equal to 5x minus 2. So on both sides, my logs and my 2's simplified out. So I'm left with just this pretty easy equation to solve. So I can just do 3x is equal to 5x minus 10. I can move that around a little bit and get 10 is equal to 2x. And then I'm left with just x is equal to 5. And so that's my answer. And then if I try plugging back in 5 here, everything works. I have 5 minus 2 is 3, so that's not negative, obviously. So plug that back into this equation, and you find that this is a valid solution. Okay, and then let's do one last example with natural logs. So we did, different bases, and remember the natural log is just a log with base e. So there's nothing really different about this than the previous ones we've done. So we have 5 ln 3 minus x is equal to 4. So I'm just going to divide both sides by 5 to get my ln alone. You don't have to do that. That just to me is easier. So I have 4 over 5. Now I can exponentiate, and I'm going to raise my equation with base e here because it's a natural log. So my natural log and my e will just cancel out. So I have 3 minus x is equal to e to the 4/5. And now I can just solve for x. And I get x is equal to 3 minus e to the 4 over 5. And just plug that into your calculator, and you end up getting x is about 0.77. Okay, and that's it for our quick review of solving logarithmic equations. I will see you guys next time.